A circle is defined as the set of points that are equidistant from a fixed point. That fixed point is called the center. Remember, is equal, so that's same, and distant is for distance. So equidistant means the same distance from a fixed point. I'm going to go back to the page where I have some more space. Let's take this point to be a point that's fixed, and I'm going to take my compass and place the center of my compass on that point. And it's called the center of the compass because that's going to become the center of my circle. And I'm going to plot a point where the pencil is, and without changing the size of the compass, I'm going to move the compass and plot another point, and move the compass and plot another point, and move the compass and plot another point. Because I am fixing the distance, all of these points are the same distance because I'm not changing the size of the compass, I am going to get a circle. I'm going to keep plotting points, and if you can imagine, I can plot an infinite amount of points. I can be here forever plotting these points, and eventually it fills in to be a circle. The way that we name a circle, like in this picture on your notes, is either with the word circle. So for example, in this picture, this is circle P, or with the picture of a circle showing its center, and then the letter of the point that names the center. So this is the way we name the circle. Any circle, this one particularly circle P. The radius is defined as the distance from the center to any point that is on the circle. So here's the center. If I measure the distance from here to a point on the circle, there is the radius of the circle, the distance. So that's why when we're using a compass, we call how wide the compass is open as the radius of the compass. Radii of the same circle are congruent. So if I draw another location where here's also the radius, well, because it's defined as the distance from the center to a point on the circle, it's going to be the same distance because that's the definition of the circle. So anywhere that I choose to draw the radius is going to be congruent, anywhere at all. Now, circles with the same radius are congruent circles. So for example, let's say I have a circle and I show this circle is A and I show its radius, and I draw another circle and I show this is circle B and I draw its radius, and I show that these two circles have congruent radii. So radii is the plural of radius. Then these circles have to be congruent because the distance from the center to the point on the circle is the same distance. So we would write circle A is congruent to circle B because they have the same radius. The diameter of a circle is defined as the distance across the circle through its center. So how could we draw that in this picture? If I go from this point on the circle and extend through the center all the way to the other side, this is the diameter. Usually we label diameter with D, the distance across the circle. Notice that it includes one radius and another radius. So another thing we can say about the diameter is it's equal to 2 radii. The diameter is twice the radius, or it's 2 radii. The diameter is a segment, so if I label the endpoints of the segment C and D, I would write segment CD is a diameter of circle P, or use the symbol to make it faster. Let's talk about graphing circles. So first of all, recall the distance formula. The distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, or the distance between the x coordinates and the distance between the y coordinates, both of them squared, added, and then take the square root. Why recall the distance formula? Well, remember how a circle is defined. A set of points that are equidistant from a fixed point called the center. It's all about distance when we graph a circle. The radius is that distance that goes from the center to the point on the circle. So we need to know the distance formula to help us to graph a circle. Let's take, for example, a circle whose center on a coordinate plane would be at the point 2, 3, and some point on the circle being 5, 7. And let's go graph those two in our grid. So there's the center, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So here's the center of our circle, and here's a point on the circle. So imagine being able to know where all the rest of the points are. Now that's kind of a really rough draft, but that's the idea. This is the center, and that is some point that's on the circle. So if the circle is all about the distance from the center to some point that's on the circle, or any of the points that's on the circle, this is a really important length to find out, that distance right there. Well, remember how that distance is defined, that's called the radius, or r. So I'm going to say, using the distance formula, now if it helps, we have these points and we can write it in the graph. But anyway, using the distance formula, the distance is the radius. So using the distance formula, the radius, or the distance from the center to a point on the circle, is the square root of x2 minus x1. That means the second x coordinate minus the first x coordinate. So 5 minus 2 squared plus y2 minus y1. So that means the second y coordinate and the first y coordinate subtracted squared. What do we get when we simplify that? 5 minus 2 is 3, 3 squared. 7 minus 3 is 4, 4 squared. Now, just a quick review. If I were, instead of having to subtract these points, to simply count the blocks from one point to the other point in the x direction, 3 blocks. In the y direction, 4 blocks. So I have the same numbers that I did get by subtracting. Just keep that in mind. We've done that in the past. So I'm going to simplify this. Square root of 9 plus 16, or square root of 25, or 5. So this radius is 5 units long, the distance from the center to a point on the circle. So if I had a measuring device that I could measure out to be 5 units long, I would go 5 units long in every direction, and I would be able to create my circle. Now, we're getting to the equation of the circle. Let's go back to this radius, finding the radius using the distance formula. So r for radius equals, now I'm going to rewrite this so I don't have to write over those numbers on how we found that radius, but keep in mind that the center is a fixed point. It is always going to be that same point no matter what other point is on the circle. But the point on the circle is constantly changing. And remember, the point on the circle was 5, 7 for this example. So things that are changing, we give variables. The 5 and the 7 are going to be changing numbers because those are the points on the circle. It's not only this point, but it's this point and 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 this point, and all of those will change. The fixed point is the center. This is fixed. The point on the circle is changing. That's why we call it XY. The point that's the center is fixed, so it stays a constant. Now, to keep it a little bit more general, because we're going to have circles in different locations, instead of saying 2 and 3, we're going to use letters that are closer to the beginning of the alphabet, like H and K. When we use more beginning of the alphabet letters, those represent constants. So here we have the radius equals the square root of x minus h squared plus y minus k squared. And to get the standard form of the equation of a circle, we're just going to get rid of this square root part, which means square both sides. So here's what it ends up looking like. Square root goes away. X minus h squared plus y minus k squared, and it is equal to r squared. That is the equation of the circle. Now you see how it related to distance formula. You don't have to memorize how we got it. You just have to memorize here's the equation of the circle. The equation of the circle for a circle whose center is at the point h, comma, k, and the radius is equal to r, the square root of that number. So let's apply what we know now about using the equation of a circle. Write the center, radius, and diameter for the graph of each equation, then graph the circle. So notice back up at the equation of the circle, the thing subtracted from x and from y makes the center. So in this first example, what do you see subtracted from x and y? Nothing. That's right. What number means nothing? 0. So the center is at 0, 0. The radius we get from this number. This number is equal to the radius squared. So how do we get to this number? We have to take the square root of that number. So square root of 36 is 6. The radius is 6. Remember, the diameter means 2 times the radius. So the diameter is 2 times 6, or 12. Now we can graph it. Center is at 0, 0. We start with that. Each point on the circle is 6 units away from the center. It's easiest on a graph to just count in the 4 directions where we can count the blocks, like to the right, 1, 2, 3, 4, 5, 6, and to the left, and up, and down. Once we have that, we can just take our pencil and do our best at creating a circle by connecting the dots smoothly. Now, if you have a compass, you could drag your compass over, put it at that point, and then connect the dots with your compass. Make sure your compass has a radius that is accurate, and there you go. Let's try a couple more, some that have some numbers in here. So again, what's subtracted from the x and subtracted from the y gives us our center. 3 is subtracted from x, so 3, positive 3 is the x-coordinate. 5 is subtracted from y. Basically take the opposite of this sign. Negative 5 is subtracted from y, because this is like y minus negative 5. This number is the radius squared. So to get to the radius, square root of 4, which is 2. Diameter is twice the radius, which is 4. Now notice, we didn't use the diameter in graphing, but it still is something that we have to know. Let's go ahead and plot the center and each point on the circle that we can get on the grid easily. 2 units away, 2 units away, in each direction. That's easy to count. Grab our compass or just graph it by freehand. Either way is good. Maybe you try to do the last one on your own. Pause the video now, come back and see how you did. Does your circle look like this? Let's try going backwards now. Write the equation of the circle with the given center and radius or diameter. Now notice radius or diameter is given, so let's watch out. So center at 1, 2. X minus the x coordinate squared plus y minus the y coordinate squared equals the radius squared. This is the radius that was given. So now I'm going to simplify because I don't like to leave 7 squared because that's not usually how we're going to see it written or how we're going to write it. 49. Here's another one with the given radius. Try to plug in the center and the radius, see what you get. You can pause the video and come back. Remember that plugging it in, it's like we're putting in the opposite sign because it's subtracting the coordinate. So -8 is the y coordinate, it becomes +8. Equals, now again I'm giving the radius. So this is supposed to be the radius squared. What happens when I square square root of 5? Let's see if you can figure it out before I get there. Just 5. Notice the last one, we're given the diameter, but the equation of the circle says radius squared. This is radius squared. This is radius squared. So we want the radius squared. So of course we can plug in the center. That stuff doesn't change. If it's a 0, we put nothing there. 0 means nothing. Equals. Now we want this to be radius squared, but this isn't radius. Remember that the diameter is twice the radius. So 2r equals 16. Therefore, the radius is half of that. The radius is 8. So 8 squared is what we're plugging in our formula, or our equation for the circle. And then 64 finally. That's not too bad, right?